In this video, we present ripples. The ripple system improves the user experience of direct and multi-touch displays through the use of application-independent, per-contact visual effects. Direct touch displays allow users to interact directly with content, and have been the focus of a great deal of recent development. Despite their advantages, direct and multi-touch systems create unique challenges. Chief among them is the ambiguity of feedback when the user encounters unexpected behavior. This unexpected behavior can come from a number of sources. The first is accidental activation. This is especially prevalent on tablet and tabletop systems. Another source is activation action problems. Different touch technologies have different peculiarities with respect to activation. Resistive touchscreens require a great deal of pressure. Vision systems, such as Microsoft Surface, can sometimes activate before the user actually touches the surface. Users also encounter the fat finger problem. This is used to describe the difficulty of selecting small objects, or in general of mapping of the user's contact area with a particular point. As we see here, the user's finger is in contact with the photograph, but it is not selected because the contact is being mapped to a point above it. Finally, users encounter background elements and disabled content. It may appear to the user that a particular item on the screen is something that they can interact with, but, in this case, the control has been disabled. In combination, these problems overlap to create an ambiguity of error. The users know that their desired action has not occurred, but they cannot determine why. Was their input not detected? Was it detected, but they missed their target? Was it detected, they hit their target, but the target does not respond to touch? Was it detected, they hit their target, it responds to touch, but does not behave the way they expected? The ripple system is intended to address these problems. Ripples provides on-contact visual response, making it clear when the system registers a touch. This also makes it clear when accidental touches are causing activations, allowing the user to correct their behavior. Ripples provides different visual effects when contacts successfully capture an element, or when they are touching inactive content, such as the background or inactive controls. This addresses the fat finger problem by indicating to users that they have missed their target. Further, the contact visual shrinks to the point used for hit testing, helping the user to learn and become more accurate over time. An early concept simply presented raw sensor data. This approach was rejected because it does not generalize to different hardware, and also does not convey enough information about the state of the system. We found that ripples might exacerbate a perception of the inevitable lag in a direct touch system. Our visual design, therefore, modifies the look of the contacts when moving, so that the lag is not as noticeable. In a multi-touch system, another source of error is physical manipulation constraints. For example, when the object reaches the maximum size allowed by the system, the user's touches will slide off the object, with no feedback as to the cause. The ripple system overcomes this by drawing a tether on the screen between the expected and actual points, demonstrating the constraint to the user. This is especially helpful to demonstrate the effects of tabletop debris. In this case, the can is preventing the list from scrolling at full speed. This is also useful in demonstrating when a user's input is being sent to a distant control, helping other users to understand their actions and input mappings. For non-continuous controls, such as buttons, we limit this visualization to the moment when an additional contact attempts to actuate the control, but is prevented by the presence of the previously captured contact. By addressing these problems, we believe that the ripple system will provide a much more pleasurable, error-free, and efficient experience with direct and multi-touch devices.